Okay, so with example 2 for 7.5, we have a box of mass 2 kilograms, which is being pushed up a rough plane by a horizontal force of 25 newtons, okay? Oh, that's terrible, hang on. Right, this whole thing is terrible. Okay, so here's our horizontal, okay, here's our slope. The plane is inclined to the horizontal at an angle of 10 degrees, and the box weighs 2 kilos, as we can see there, so we've got a 2g force going down. The horizontal force of 25 newtons, that's being applied, again, horizontally to the box. So it's being applied in that direction, 25 newtons. And that's obviously going to, I'm just going to, again, use a different colour for the different direction. That's going to push the box up the hill, which means that we're going to have friction working opposite to that because it's a rough plane. So friction acting down the hill, and it is the coefficient of friction between the box is 0.3 R, and then the last thing I need to put in is that R resultant normal force acting perpendicularly to the plane. Okay. So there's our scenario. Given that the coefficient of friction between the box and the plane is 0.3, find the acceleration of the box. So with our F equals ma, okay, we know that F equals 2, we know m equals 2, we need to find F, and we are trying to find A. That's our main thing that we're wanting to solve for. All right. So to get our force, we need our net force. So we can resolve in a few different ways. So if we resolve vertically to start off with, okay, or I should say, sorry, inline. So if we resolve going kind of up the plane, okay, then we can see that we have R, okay, which is acting in the vertical direction. Here we've got this 2g, which is acting at an angle of, so it's going to be negative 2g because it's going down, so minus 2g, and again for that we're looking at the adjacent side to the angle there, so that's our 10 degrees adjacent side, so cos 10. And then we also have a vertical component of that 25 Newton force as well. And again, this is parallel, so we've got an angle of 10 degrees in here too, because this is parallel to our horizontal. So we've got 10 degrees, we're looking at the vertical, so that's the opposite side. So plus 25 sine 10, okay, and that equals to our mass times acceleration. Sorry, I just realized that this should be this should be negative here for the 25 sine 10, because this force is acting downwards into the box. Okay, so it's applying, even though it's moving across, it's applying a downward pressure into the plane. So that should be, so that's actually in the same direction as the 2g. So that should be negative 25 sine 10. Now again, for this one, because you've got no net vertical movement of the box, okay, that mass times acceleration is equal to 0. And from here we can go through to solve for R. So R would be equal to 2g cos 10 plus 25 sine 10. Okay, so then R would be quickly work it out. Okay, and I get R equals 23.64 newtons. Okay, from here we can then, we want to find the acceleration of the box, and obviously the box is moving up, or it's moving in the horizontal direction, so we then want to resolve horizontally. Okay, so if we're resolving horizontally, we're looking at these parts here. So we've got friction, so 0.3. We'll look at the horizontal first horizontal force first. So we've got the 25 newtons coming in here. So that force is then, for the horizontal component, we're looking at 25 cos 10. Okay, because we've got the 10 degrees and we're looking at the adjacent component. So 25 cos 10. Then acting opposite to that is the 2g, so minus 2 g sine 10. Okay, and then minus 0.3 r, and that's equal to mass times by acceleration. Okay, so 25 cos 10 minus 2g sine 10 minus 0.3 times by 23.64, okay, equals, the mass is 2, and we're trying to solve for the acceleration. Okay, so again, quickly, I'm just going to work this out. So we've got 25 cos 10 minus 2 times 9.8 times sine 10 minus 0.3 times r. Okay, so I get from here 2a equals 14.12. So therefore a is equal to, a is equal to 7.06 meters per second to the power of -2. Okay. Now, in general, we've got the maximum significant figures we've got here is 2. So I'm going to give this to 2 significant figures. So my acceleration will be 7.1 meters per second squared. Lovely. All right, there we go.